Okay, so what we're going to be looking at now is that we're going to be looking at properties of exponential functions. We're going to look at something that's fairly important. You use this in money management and savings and everything. And so the first thing we want to do is plug into this formula into our calculators with these windows. So y equals parenthesis x plus 1 over x, close parenthesis to the x. And we want to take this and graph it with the windows as the x min is 0, max is 5, y min is 4, y min is 0, y max is 4. And we'll graph it. And when you graph it, it looks something like this. Okay, it's just a nice little growth. This kind of calculates how much you would make if you compounded something once a year, twice a year, 3 times a year, 4 times a year, 5 times a year, so on and so forth. And so now we're going to take this and we're going to expand our windows and take the x and bring it out even further. Now if you bring it out even further, you'll see it looks like this. Okay. And as we see, we kind of looks like we're kind of topping out someplace. Okay, we're kind of hitting a roof on this account. And what this is that this number where we're hitting our top is called Euler's constant. And it's used in something called continuous compounded interest. Now, if you go to a bank or if you want to save money or if you take out a loan, they say, okay, your interest is going to be compounded this way. It could be compounded monthly, which means every month they add in interest or they remove interest, or they multiply how much is in the account by the interest rate. Okay. And so if you think of a savings account, if you have $1 and you have 5% interest compounded monthly, after 1 month they'd give you 5 cents. Okay. After the next month they would give you 5% of $1.05. So it's added on. Okay. And so continuous compound interest is if, okay, instead of doing it every day, month, minute, second, nanosecond, continuous means, okay, what if it's always gaining interest? So it's non-stop gaining interest on the amount. Well, what Euler, or what other mathematicians found, and Euler was the one that kind of gets credit for it, he was the one that started to use the E. It's comes up as it comes up as an irrational number, like pi or phi. Okay, this number goes off into infinity. It's an irrational number. And so this is the number that this is the constant we will be using whenever we're doing our continuous interest rates. And the formula for this is called PERT, is kind of the a way to remember it. A, or the amount in the account afterwards, is equal to P, the principal, times Euler's constant to the power of the interest rate in decimal form times the number of years, or PERT, P-E-R-T. Okay. And this is your continuous compound interest formula, and that's what we're going to be mostly using. So let's say we have here Connor wants to buy stock into Surge, the energy drink. Connor visits Tina and Anna Grace at Tag Bank. They tell him that they offer continuous interest at 5%. If Surge stock costs $1,500, how much would Connor need to deposit to be able to buy stock in 5 years if the stock stays the same? So what are the parts that we know? Okay, well, A was the amount that he wants in the account at the end. Well, how much does he want in the account at the end? He wants to be able to buy the stock of Surge, which is about $1,500. So your A will be $1,500. Your P, or your principal, that's how much is originally deposited. How much was originally deposited? Well, in this setup, that's what we're trying to find. How much does he need to deposit? So that's our question mark. What was the interest rate in this problem? The interest rate in this problem is 5%, so our R would be 0.05. And then our time is 5. Okay, once in 5 years. So when we set up this problem, we would have 1,500 is equal to P e to the 0.05 times 5. So when we set this up and solve it, it'd be 1,500 P e to the 0.25. Solve for P means that we're going to have P is equal to 1,500 all over e to the 0.25. And so when you type this into your calculator, you'll just go e to the power of 0.25. And then when you solve it, you end up seeing that you get about $1,168.20. So that's how much he would have to deposit into the bank to be able to get $1,500 in 5 years. So that much dollars. Okay? Okay, Martin is trying to save for college. He deposits $4,000 into a savings account. What is that is compounded continuously. So again, we're going to use PERT at 8% after 6 years. How much does he have saved? So, what is our P? So what's the principal amount? It's $4,000. That's how much he originally deposited. Our rate is 8%, so it's 0.08. And our T, or the number of years, would be 6 years. So when we plug this into our formula, we're going to have A sub 6. Okay, so the amount in 6 years is equal to 4,000 e to the 0.08 times 6. And then we would multiply this through and solve it. And we would see how much we would get, which would be about $6,464 and about 30 cents. And that's how much Martin would have after 6 years for saving up for college. Okay. As you see, it grows pretty quickly. So, your IRAT for this section. Your IRAT for this section is Samantha deposits $1,500 into a savings account. Its interest rate is about 4%. After 10 years, how much does she have? And then after 20 years, how much does she have in the account? So you're going to have two answers here. You're going to be using PERT. A is equal to PERT. You're going to use this formula, and you're going to find how much is in the account after 10 and after 20 years. Okay. So that's what you're going to do for this one. Just use this formula, plug in the amounts. Make sure you have your calculator that has an E button on it, so that you're able to do this. You're going to have to use Euler's constant.